In the rapidly evolving landscape of software development, artificial intelligence has emerged as a game-changing tool. Claude, an advanced AI assistant developed by Anthropic, represents the cutting edge of this technology. By integrating Claude into your SwiftUI workflow, you'll gain access to unprecedented levels of efficiency and insight. Let's explore how this powerful AI can transform your development process. Introducing Claude 3.5 Sonnet, the most intelligent model in Anthropic's Claude 3 family, is a powerful AI assistant that can revolutionize your coding workflow. With its advanced natural language processing and deep understanding of multiple programming languages, Claude 3.5 Sonnet can assist developers at every stage of the software development lifecycle. It excels at generating efficient, clean code snippets, explaining complex algorithms, debugging tricky issues, and even suggesting optimizations for your existing codebase. Whether you're working on SwiftUI, Python, JavaScript, or any other popular language, Claude 3.5 Sonnet can act as your intelligent coding companion, offering insights, answering questions, and helping you tackle challenging programming problems. Its ability to understand context and provide detailed explanations makes it an invaluable tool for both seasoned developers looking to enhance their productivity and beginners seeking to learn best practices in coding. In this SwiftUI course, we'll explore how to transform Figma designs into functional code using Claude AI. We'll begin by focusing on 3 key screens, learning to replicate their original designs with precision. You'll learn how to evolve static layouts into interactive interfaces, seamlessly connecting various elements. As we progress, we'll dive into more advanced coding techniques, incorporating functions and implementing view models. We'll leverage Claude AI to implement and refine our SwiftUI code. This hands-on approach will not only provide you with valuable skills, but also demonstrate the exciting potential of integrating AI into your development workflow. By the end of this course, you'll have gained practical knowledge and experience in creating engaging iOS applications using SwiftUI and AI-assisted coding techniques. Let's embark on this innovative learning experience. The field of artificial intelligence is advancing rapidly, with numerous AI models emerging as notable contenders. Among these, Claude 3.5 Sonnet stands out due to its remarkable performance in a wide range of benchmark tests. It excels in graduate-level reasoning, undergraduate knowledge, and code evaluation, which we want to explore in this course. For developers, Claude offers valuable assistance in coding and productivity enhancement. It can write, edit, and debug code with advanced troubleshooting abilities. It performs at extracting relevant information from documentation, categorizing and summarizing data, and handling complex inquiries, making Claude's versatile skill set a powerful ally for your projects. To effectively follow this course, it's highly recommended that you invest in a pro subscription. This strategic upgrade will significantly enhance your learning experience by providing you with 5 times more usage compared to the free plan, granting access to all 3 models, enabling you to create projects for efficient collaboration with Claude on your SwiftUI code and documentation, ensuring priority access during peak usage times, and giving you early access to cutting-edge features. By making this investment in your SwiftUI development journey, you'll be equipping yourself with the most powerful tools and resources available, setting a solid foundation for your success in mastering SwiftUI and building advanced iOS applications. Let's begin building our SwiftUI project with Claude AI. First, navigate to the left menu and locate the Projects option. Click on Create Project to initiate the process. Provide a descriptive name for your project and include a concise summary in the description field. This will help you easily identify and reference your project in the future. Remember, a well-organized project structure sets the foundation for efficient development. To set up Claude for our project, we'll give it specific rules for how to act and answer in all chats within our AI app. For coding questions, Claude will follow these steps. 1. Always give full code for functions that are modified. 2. If possible, give full code to the full component. And 3. For large files, only give the code that changes. These rules make sure Claude gives complete code examples when needed, but for big files, it only shows the parts that have changed. This helps keep things clear and saves time. To optimize Claude's SwiftUI code generation, we'll implement a final custom instruction defining the role of a senior SwiftUI developer. This instruction will ensure comprehensive coverage of the job's key aspects, resulting in the highest quality output. If you need guidance on describing the role and its associated tasks, use the following prompt as a template. This approach will equip Claude with the necessary context to emulate an experienced SwiftUI developer's expertise effectively. Once you've generated the prompt and are satisfied with the result, proceed to copy the revised text. Insert this text into your custom instructions to update them with the new content. As this conversation doesn't involve coding or technical elements, you can safely delete it. Now that we have everything set up, we're ready to harness Claude AI's capabilities and put its skills to the test. In the first segment of the course, we'll explore how Claude can generate SwiftUI code from a simple screenshot. We'll focus on 3 specific screens throughout this process. Make sure to save the 3 screens in JPEG or PNG. After generating the initial code, we'll take it a step further by diving into essential SwiftUI concepts. You'll learn how to refine your user interface with proper spacing, create effective layouts, apply powerful modifiers, and build reusable components. This hands-on approach will provide you with a solid foundation in SwiftUI development, enabling you to create polished and functional user interfaces. Let's upload the sign-up screen and observe Claude's initial response without additional prompts. At first glance, Claude may appear to understand the first task of generating SwiftUI code for our layout, and it even provided a brief explanation. Claude will actually describe what it sees in the image and await specific instructions for code generation or detailed analysis. Copy and paste the generated code into your SwiftUI project. Be aware that Claude may create struct names based on what it observes in the screenshot, which could lead to errors if you're adding this to an existing content view file. Ensure the struct name matches your project's structure. Once added, you should see a preview of the AI-generated layout. While Claude understood the basic assignment, the result may be below expectations. Let's refine our approach by using a specific prompt to guide Claude towards a more accurate and tailored implementation. Let's repeat the sign-up screen implementation. This time, we'll enhance our approach by incorporating a well-crafted prompt to guide Claude's assistance. Remember, while there's no such thing as a perfect prompt, we can follow some best practices to improve our results. First, clearly state the task or question at the beginning of your message to Claude. Next, provide relevant context and details about our SwiftUI project to help Claude understand our specific needs. Finally, if we're dealing with a complex feature, break it down into smaller, manageable steps. Let's examine how Claude handles the task with our updated prompt. We'll replace the previous SwiftUI code with a newly generated version. How amazing is that? The new result demonstrates significant improvements, showcasing a well-structured layout with input fields and action buttons for each element. It's important to note that while Claude AI serves as a valuable assistant in your development workflow, potentially saving considerable time when starting a project, it's not intended to replace the developer. It is crucial to maintain organization as your code base expands. As you engage in multiple conversations about different aspects of your app, it's highly recommended to rename your chat sessions appropriately. This practice ensures easy reference in the future, allowing you to quickly locate specific discussions about UI components, data flow, or any other relevant topics. When working with Claude on any projects, it's important to be aware of token limits. You'll receive a warning when only 10 messages remain before a potential 3 to 4 hour timeout. To optimize your workflow, start new chats frequently and separate each task into its own chat. Utilize the project's feature to maintain context across multiple chats without repetition, allowing you to start fresh conversations while retaining relevant SwiftUI code and documentation context. This approach is vital because Claude reviews all previous context for each new request, rapidly consuming tokens. By creating separate chats for different components of your SwiftUI project, you'll conserve tokens and avoid premature rate limits. Repeat the same process for the 2 remaining screens, creating a new SwiftUI file for each one. As you work, consider Claude as a powerful tool to enhance your productivity and streamline your coding process. When developing with SwiftUI, it's crucial to review and customize the generated code. This ensures alignment with your specific project requirements and best practices. In the upcoming sections, we'll focus on enhancing these screens to match the Figma design. Remember, while Claude can provide a solid starting point, your expertise as a developer is essential in refining and perfecting the final product. Let's enhance our basic sign-up screen to create a more refined and functional interface. First, we'll address the background color discrepancy. The current linear gradient doesn't match our intended design, so we'll remove it. Referring to our Figma design, we see that it uses a solid color for the background. To implement this, copy the hex code of the background color from Figma. Then, in Xcode, navigate to your asset catalog. Create a new color set by right-clicking in the asset catalog and selecting New Color Set. In the Inspector panel, adjust the settings to input a custom color and paste the copied hex code into the appropriate field. Finally, rename this color set to BG color for easy reference in our SwiftUI code. This approach allows us to maintain consistency with our design and easily update the color across the app if needed. Apply the custom color we created earlier, and add the Ignore Safe Area modifier to ensure the background color extends beyond the safe area, covering the entire screen. To accurately recreate the layout from the original design, we'll need to closely examine the design specifications in Figma's Inspector panel. Pay careful attention to the dimensions of UI elements, typography details, including font family and size, color schemes, as well as spacing and padding values. To create the header for our SwiftUI app, we'll group the CPU symbol and title within a VStack. We'll leverage the power of SF symbols and set its font size to 72, eliminating the need for manual frame adjustments. The title text will stand out with a size of 50 and a regular font weight. While it offers various design options like serif, monospaced, and rounded, we'll stick with default for a clean look. To ensure perfect alignment, we'll apply the multi-line text alignment modifier, centering all elements within the VStack. Finally, we'll set the VStack's foreground color to dot primary, creating a cohesive and visually appealing header that adapts seamlessly to different color schemes. In the next VStack that contains the two input fields, set the spacing to 20 and remove any existing padding. To edit the custom input field component, right-click on it and select Jump to Definition. Remove the shadow effect from this component. We'll utilize Apple's integrated text styles, specifically .subheadline, as shown in the design. This system-provided text style ensures consistency across iOS devices and automatically adjusts for accessibility settings. Set the foreground color to .secondary for a more subtle appearance. Adjust the frame by setting the max width to .infinity and the alignment to .leading. This will make the input field span the full width of its container. The default padding is 16, so modify to 12 for a slightly more compact look. Finally, add an overlay to create a subtle border around the input field, enhancing its visual definition without being too prominent. When organizing reusable components in SwiftUI projects, consider the project's size and complexity to determine the best approach. For smaller projects, keeping related components in the same file can enhance understanding of the view structure. However, larger projects benefit from separating reusable components into individual files. In our case, create a new file named Custom Text Field to improve code organization, readability, and maintainability. This approach also facilitates component reuse across different parts of your app. Let's refine our layout by adjusting the spacing in the header VStack to 20 points for better visual balance. Next, we'll group all the remaining elements inside the input field's VStack. This organization will prove useful later. Select everything from the Already Have an Account section to the Terms of Service and relocate it inside this VStack. Here's a time-saving tip for efficient code navigation. For single-line code, position your cursor at the beginning of the line and use Option plus Command plus right bracket to move it down or left bracket to move it up. For multi-line code blocks, select the entire section before using these shortcuts. In this case, we're moving the entire H stack up between the two input fields. Let's move on to the Account section. First, we'll modify the existing text elements. Copy the text content and position it above the button, removing the phrase "log in" from the first text view. Apply the .subheadline font style to both text views and set the color of the first one to .primary. For the second text view, keep only the login part. Finally, optimize the layout by removing any unnecessary padding around these elements. Add a divider to create a visual separation. Then, remove the V-stack and its padding that was wrapping the two sign-up buttons. For the buttons at the bottom, remove any existing padding on the H-stack, set the spacing between them to 40, and eliminate the spacer. Now, focus on the main V-stack. Adjust its padding to 20 and set its spacing to 50. This creates two distinct sections, each containing a V-stack with 20-point spacing between elements. The 50-point spacing between these sections ensures a balanced layout. These changes will result in a cleaner, more organized interface. Adjust the Continue button's padding to 12 points, as it's a one-time use element and doesn't require a separate component. Next, we'll extract the Sign Up button into its own reusable component. Create a new file named Login Button and move the button code there. Remember to update the struct name to match the new file name. After this, return to your SignupView and import the newly created Login Button component. Lastly, enhance your preview by adding any missing parameters to ensure complete representation of your UI to start editing your component. We'll replace the SF symbols with custom logo images from our Figma design. First, import these images into the Assets catalog. In the image view, remove the system name parameter and keep only the variable name. Position the image view to the right of the text view and set the spacing to 12 points. Apply a foreground color of primary and modify the padding to 12. Next, implement a border similar to the custom text field component for consistency. Return to the sign-up view and update all SF symbol references with the corresponding imported asset names. Finally, in the bottom H stack, set the font to subheadline and the foreground color to primary. With these adjustments, we'll have successfully refined our layout, creating a more polished and cohesive user interface. With the layout done, we can still enhance our sign-up screen's visual appeal by adding interactivity and animation. We'll focus on implementing the subtle glow effect visible in our Figma design. This effect can be challenging to implement, but here's how we can achieve it with Claude. First, locate the glow layer in Figma. In the Inspector panel, you'll notice two gradients. Activate developer mode and copy the SwiftUI code for the first glow and paste it in your chat box. Then, take a screenshot of all the colors used in the gradients. We'll use both the code and the color information to generate our custom glow effect by providing a clear instruction for Claude to generate the code. Create a new file named gradient border small and paste your code there. Keep in mind that while we're using AI assistance, the generated code may vary slightly each time. You might need to fine-tune the result to achieve the optimal effect. In our implementation, we'll also incorporate a subtle rotation animation for the glow. All the sample code used in this video can be found in our written section. While the effect may be subtle in light mode, switching to dark mode will reveal the beautiful, rotating gradient. Create a new file called gradient border large to complement our existing border component. Copy the code from your previous gradient border small file and make the following adjustments. Rename all instances of gradient border small to gradient border large, remove the opacity modifier, and increase the blur radius to 30. Now, return to your sign-up view and add both gradient border large and gradient border small components immediately after the background color in your Z-stack. Remember, the order of elements in a Z-stack is crucial. As shown in the code, the background color is at the bottom of the stack, followed by gradient border large and then gradient border small. This layering creates a visually appealing gradient effect, with each subsequent layer building upon the previous one to form the final composition of your view. In our final enhancement to the sign-up view, we'll bring the header section to life by animating both the symbol and title. This step introduces an exciting feature that streamlines our development process, the ability to provide Claude with our entire project context. By uploading all the files from our Xcode project, except images, which aren't currently supported, we give Claude a comprehensive understanding of our codebase. This approach eliminates the need for constant copy-pasting and allows for more targeted assistance. With our project files now uploaded, using only 3% of the available capacity, we're ready to tackle the animation challenge. We'll craft a precise prompt for Claude to generate a pulsing and rotating animation effect. As we await the code generation, we'll also explore the artifact feature, which Claude uses to present substantial, self-contained content in a separate UI window. This feature is particularly useful for complex code snippets or detailed explanations that you might want to reference or modify later in your SwiftUI development process. Create a new file and name it LogoView. Copy and paste the generated code into this file to implement the logo animation. The result is impressive, a subtle, smooth animation created instantly. Notice how the code includes the gradient border colors in the CPU symbol, as requested in a previous prompt. Next, replace the content in the header V stack with this newly created LogoView component. We've now successfully transformed a Figma design into an interactive SwiftUI element with Claude's assistance, demonstrating how AI can significantly enhance your development workflow. For better organization, let's structure our project by grouping related files into specific folders. Create folders such as Views, Components, to categorize your Swift files appropriately. Let's continue building upon the foundation of our Discover screen, which we initially created with Claude's assistance. In this next phase, we'll focus on improving the user experience by enhancing the scrolling functionality, refining our custom-featured card, and implementing interactive elements. We'll connect our button components to modals and other views, creating a more dynamic and engaging interface. As we progress, we'll utilize SwiftUI's powerful features to ensure smooth navigation and seamless transitions between different parts of our app. It's really amazing how Claude was able to generate this SwiftUI code from a simple screenshot. Although it's not perfect at first glance, we are saving a considerable amount of time structuring our code. In this section, we'll enhance our SwiftUI layout skills, which are crucial for creating outstanding applications. We'll start by improving the consistency of our screens. First, wrap the scroll view inside a Z-stack and apply the custom background color and remove the alignment and padding. To refine the navigation bar, adjust the two SF symbols by setting their size to 34 and applying a black color with 10% opacity. For both buttons, use the image view with equal.circle for the left symbol and ellipsis.circle.fill for the right symbol. Here we noticed from the design that the equal sign is using another color. Here's a simple way to achieve that. Replace foreground color by the foreground style modifier to color the symbol. The first color, .black, is applied to the primary part, the equal sign, while the second color is used for the secondary part, the circle border. This approach gives you precise control over the appearance of multi-part SF symbols in your SwiftUI project, ensuring that your buttons match the design specifications. Change the Discover title by changing its style from Title2 to Title and set its foreground color to primary. Next, refine the menu's appearance by setting the font style to .subheadline and increasing the font weight from regular to medium when not selected. To visually separate the menu items, we'll create a subtle divider using a rectangle. Set its color to black with 10% opacity and dimensions to 1 point wide and 30 points tall. Place this separator right after the text view inside the for each loop. However, we don't want a separator after the last item. We'll implement a conditional statement to check if the current tab is not the last item in the tabs array before rendering a separator. It ensures that the separator is only created between items, not after the last one. Let's enhance the layout of our tab bar view. Begin by adding some padding to the H stack. Apply a top padding of 25 points and a horizontal padding of 20 points. Now, let's focus on the featured section. Adjust the spacing to 20 points and remove any alignment. For the text, use large title and remove the bold font weight. move the foreground color modifier to the H stack and set the font size of the symbol to 24 points. Next, add a horizontal padding of 20 to the main V stack. Then, on the H stack that contains the two featured item view, modify the spacing to 20 and embed it in a scroll view with horizontal scrolling enabled, and hide the scroll indicators for a cleaner look. To prevent clipping issues, move the horizontal padding of 20 points from the main V stack to the H stack inside the scroll view. This adjustment will ensure proper spacing. Apply the same padding to the first H stack as well. For a polished appearance, add the following shadow effect to the scroll view rather than the H stack to avoid clipping. Remember, a solid understanding of stack views in SwiftUI is crucial for placing modifiers correctly and achieving the desired layout. Now let's enhance the featured item view to align it more closely with our original design. First, we'll modify the color variable to accept an image of type string. While you can still use a solid color if preferred, incorporating a vibrant background image can significantly improve the visual appeal. This modification will obviously cause some errors inside the parameters of the component. To implement this change, create a new folder called Images in your asset catalog and import all the provided image assets. Now, let's update the two instances of our featured item view component to use the new image parameter instead of the previous color parameter. Insert the name of one of the background images you've recently added to your asset catalog for each instance. Use different background images for each instance to create visual variety, ensuring the image names exactly match the file names in your asset catalog. In the Z stack, remove the rounded rectangle and its modifiers. Replace it with an image view that references our new image variable. Apply these modifiers to the image. Use .reusable with aspect ratio set to fill to ensure proper scaling, and set the frame height to 60. To improve our component structure, let's make some adjustments. First, wrap all elements in a Z stack, removing all parameters from the V stack. This will serve as our main container. Next, eliminate any redundant Z stack inside the V stack to streamline our layout. Group the two text views together by placing them in a V stack, which will help organize our content vertically. Then, reposition the image view by moving it outside of this V stack, immediately following its modifiers. This change will give us more control over the image's placement. Finally, set the alignment of the outermost Z stack to top, ensuring the image view aligns neatly at the top of our view. To style your title text, apply the Title 3 font with a bold weight and primary color. Center align both text elements using the multi-text alignment modifier. Set the main V stack to a fixed size of 172 by 214, remove any padding and shadow, and adjust the corner radius to 20. To properly display the image, add the clipped modifier to the image view and position it at the top by inserting a spacer after the text elements. For correct text positioning, add a top padding of 40 to the V stack containing the texts, creating a 40-point gap between the image edge and the text. Apply horizontal padding of 20 to this V stack as well. Finally, configure the image view by setting the symbol size to 24, adjusting the padding to 16, and applying a vertical offset of 32 points. To expand your scroll view with more content, you can create additional instances of the featured item view component. To save time, consider using the AI assistant to generate 3 new instances with related topics. Simply request the AI to provide the code for these new instances, then copy the generated code and paste it inside your scroll view. This approach will efficiently populate your view with diverse, relevant content while saving time. Let's advance to the trending section of our SwiftUI app, having successfully implemented the featured section. To maintain visual consistency, we'll replicate the styling of the featured title for our trending title. This approach not only ensures a cohesive design, but also streamlines our coding process. You can efficiently achieve this by duplicating the code used for the featured title and simply modifying the text content. This technique allows us to reuse our existing SwiftUI components, saving time and reducing the likelihood of errors. Remember, consistent design elements contribute to a more polished and professional-looking user interface, enhancing the overall user experience of your iOS application. Let's enhance our trending item by replacing the color variable with an image variable of type string. Update all 4 instances where we previously used color, now using image instead. We'll utilize images from our asset catalog for this purpose. Next, focus on the main H stack. Remove the rounded rectangle and its associated modifiers. In its place, add an image view with the following modifiers: resizable for flexibility, scaled to fill to maintain the aspect ratio, a fixed frame of 60 by 60, and clip shape using the rounded rectangle with a corner radius of 10 to achieve rounded corners. This adjustment will give our trending item a more visually appealing and dynamic appearance, incorporating actual images rather than solid colors. Let's refine our layout to create a more polished look. First, reposition the index text by moving it and its modifiers after the image view. We'll also remove the spacer to tighten up our design. To enhance readability, update the font of the index text to body with a semi-bold weight and remove the secondary color. Now, let's focus on the V stack containing our 2 text elements and set its spacing to 4 points. For the first text, use the body font style with semi-bold weight. The second text should use the footnote style for a subtle contrast. Finally, let's adjust the main H stack and decrease its spacing to 10 points, and replace the padding with a frame modifier. Set the frame width to 300 points and align it to dot, leading for a more structured layout. With the component completed, let's enhance our SwiftUI layout by making it scrollable and displaying 2 columns of rows. First, wrap your for each loop in a V stack, setting the spacing to 15 points. Then, embed this V stack inside a horizontal scroll view with hidden indicators for a cleaner look. To achieve the 2-column layout, place the V stack inside an H stack. Now, adjust the for each loop parameters. Replace the current content inside the parentheses with a range of 0 to 4. This creates a loop that iterates 4 times, with index representing values from 0 to 3. Update the item parameter of your custom component to use trending items index. This ensures each item from the trending items array is passed to the view, using the index to access the corresponding array element. To create the second column, duplicate the VStack content and place it immediately after the first one within the H stack. Set the H stack's alignment to .top and its spacing to 40 points, and add a horizontal padding of 20 points. Finally, populate your scroll view with new instances by using AI to generate 4 additional items. Modify the second for each loop to use the range 4 to 8. This will display items 5 through 8 in the second column. Now that we've successfully optimized the DiscoverView screen, we have a visually appealing layout with smooth scrolling functionality. To enhance the user experience further, let's explore adding interactivity to the navigation bar. Since we don't have a specific design for this feature, we'll use AI's assistance to generate ideas. First, navigate to your AI project and replace the existing DiscoverView file with the updated version. Next, we'll consult Claude for suggestions on potential navigation bar interactions. After reviewing the AI's recommendations, I'll just implement the most suitable option. The results are impressive, demonstrating how AI can provide context-aware suggestions that align with our project's goals and SwiftUI framework. Let's add one final feature to wrap up this section, with Claude's help. We'll create a dedicated view for the featured and trending sections. Since we don't have an official design for this view yet, we'll implement a basic structure to build upon later. First, navigate to the Featured Section view and create a new file called Featured View. In the Featured Section view, remove the VStack and its corresponding brackets. Now, wrap the H-stack containing the featured titles inside a navigation link. Set the destination of this navigation link to the newly created featured view. This will allow users to tap on the featured section and navigate to a more detailed view. By implementing this feature, we will need to slightly refactor our data structure. Let's begin by creating a featured item struct right after our featured section. This struct will represent individual items in our list or collection view, each with a unique identifier, icon, title, description, and image. Next, we'll set up a featured items array to store these featured item objects efficiently. Now, let's refactor our scroll view. Select all instances of featured item view and place them inside our new array, separating each item with a comma except for the last one. To streamline our code, we'll rename featured item view to featured item. Use the refactor tool by right-clicking on featured item view, selecting refactor, then rename. This action will update all occurrences, but be careful not to change the last instance, which is our card component. Finally, we'll adjust the content of our featured section to align with these changes, ensuring our SwiftUI app runs smoothly with this improved structure. In the scroll view, insert the featured item view component with all of its parameters. Featured items index is accessing an element of the featured items array at the position specified by index. The dot notation is used to access properties of the featured item object. This code is creating a view to display a featured item, passing in the specific details, icon, title, description, and image, from an item in the featured items array at the position indicated by index. Embed the featured item view component inside a for each loop that will iterate 5 times, for indices 0 through 4. The index variable is used inside the closure to access the correct item from featured items for each iteration, allowing the creation of 5 different featured item view instances, each with its own data. The number of instances shown depends on the data you provide. It's important to ensure that your loop range doesn't exceed the total number of available objects, as this can lead to runtime errors. For this exercise, we'll use 15 AI-generated instances related to our topic. Now switch to the featured view to start building a simple layout. First, let's define a flexible 2-column grid layout. The columns constant is an array containing 2 grid item objects, each set to .flexible. This configuration creates a grid with 2 columns that automatically adjust their widths to equally share the available horizontal space. The flexibility allows the grid to adapt to different screen sizes and orientations, making it ideal for responsive layouts such as photo galleries or product lists. Replace the default view with a scroll view to enable scrolling. Inside this scroll view, insert a lazy V grid to display a collection of featured item view instances. The lazy V grid will grow vertically as more items are added, arranging them into columns as defined by the columns parameter. Set the grid spacing to 20 points for visual separation. Within the lazy V grid, add a for each loop that iterates over all items in the featured items collection. The item in syntax opens a closure where item represents each element from featured items in turn. Inside this closure, create a featured item view for each item, populating it with data from the corresponding featured items element. This approach is a standard SwiftUI pattern for dynamically generating grids or lists based on a data source, ensuring efficient updates and performance. Finally, apply default padding to the lazy V grid and add navigation modifiers to the scroll view. However, we've encountered a visual inconsistency in the trending section. While the shadow appears correctly on the featured item view, it's missing when transitioning to the featured view. To resolve this, move the shadow from the scroll view to the Z stack within our component. But this adjustment causes the trending section shadow to be clipped, but it renders correctly in the featured view. To fine-tune the layout, add a bottom padding of 30 to the scroll view. But this will create a 50-point gap between the featured and trending sections, which can be balanced by applying a negative top padding of -30 to the trending section. These modifications will effectively resolve our layout issues and ensure consistent visual presentation across views. We've enhanced the trending section by implementing interactive features. While we've utilized Claude's assistance for the implementation, it's important to note that there are multiple approaches to achieve similar results in SwiftUI. To reinforce your learning, practice applying these concepts to the trending section or continue using Claude for guidance. Before we conclude this layout, let's address a crucial optimization. Our trending item view currently has a fixed width of 300, which doesn't adapt well within the trending view. To improve this, we'll introduce an isFixedWidth property to the trending item view. This Boolean parameter will allow the view to adjust its width flexibly based on its context, ensuring better responsiveness across different device sizes and orientations. On the VStack, implement a conditional statement to dynamically add a spacer based on the isFixedWidth value. When isFixedWidth is false, insert the spacer to push the content to the leading edge, ensuring a left-aligned layout that expands to fill the available width. Next, focus on the H-stack and apply two crucial frame modifiers to control the trending item view's width and alignment. Use a ternary operator to set the width, 300 points when isFixedWidth is true, or nil for flexible width when false. For the second frame modifier, set max width to nil when isFixedWidth is true, allowing unrestricted width. Conversely, when isFixedWidth is false, set max width to infinity, enabling the view to expand and occupy all available space. In the trending section's scroll view, locate the trending item view within both for each loops. Add the isFixedWidth parameter to each trending item view and set it to true. Next, navigate to the trending view and add the same parameter, but this time set it to false. These modifications will enhance the responsiveness of your component, allowing it to adapt fluidly to various screen sizes. By implementing these changes, you're ensuring that your SwiftUI interface remains visually consistent and functional across different devices and display configurations. In the next section, we'll enhance the image generator view, so let's connect this card to that specific view before we conclude. Navigate to your featured item view. First, declare a property called destination of type AnyView. This versatile property allows you to store various view types, giving you flexibility in your navigation setup. Now, wrap your existing Z-stack inside a navigation link. Set the destination parameter to the destination property we just created. This powerful combination enables seamless navigation to any view you specify. When you tap this link, the app will smoothly transition to the view defined by destination, sliding in from the right side of the screen. A back button will automatically appear in the top left corner, allowing you to return to the previous screen. Your destination view isn't limited. It can be anything from a simple text view to an intricate custom creation. Navigate to the featured section, and we'll now implement a function to dynamically set navigation link destinations. Create a function named destination4item that takes a featured item as input and returns an AnyView. Inside the function, use a switch statement to determine the appropriate view based on the item's title. For any unmatched titles, return a default Coming Soon text view. Next, update the featured item view. Add a destination parameter by calling destination4item with the current featured item. This implementation creates a dynamic navigation system. Each featured item view in the scroll view will have its own specific destination when tapped, based on the properties of the featured item it represents. For example, tapping an image generator item will navigate to an image generator view, while items with unrecognized titles will display a Coming Soon message. Navigate to the featured view file. Copy the previous function, but remove the featured case. Instead, set the destination for each featured item view by calling the destination4item function. After implementing these changes, your app will feature interactive cards that respond to user taps. When a user interacts with any card, a navigation link activates, smoothly transitioning to a new view. Tapping on featured lead users to the featured view, presenting all featured items in an organized grid layout. For other cards that don't have fully implemented features yet, tapping leads to a Coming Soon placeholder view. Tapping on specific cards, such as Image Generator, takes users to their respective dedicated views. This concludes the first part of our SwiftUI course. In the upcoming second half of the course, which will be available on our website, we'll delve deeper into enhancing your app's functionality and user interface. We'll focus on improving the image generator view by refining its design. You'll also learn how to implement sophisticated components in the SignupView, making it more user-friendly and robust. Additionally, we'll explore Cursor, an AI-powered coding assistant that can significantly boost your productivity when working with SwiftUI. Stay tuned for these exciting topics that will take your SwiftUI skills to the next level.